Well, hello, my name's Tony. I live in a city called Brisbane, Australia. It's on the east coast of Australia. It's got a nice beach. When you come to visit me, we'll go there. All right? I'm going to tell you about trees that grow. I got into trees that grow for a reason that I'm going to go into detail about. So I'm going to give you the reason why I even looked at this paper. And I hope that you can sympathise with that reason. It's a reason that comes up all the time. You know, when I try to ring a government agency and they say things like the computer says no, that kind of thing, I always think of this problem. All right, like their data didn't fit into their data type is what they told me. They didn't say those words. That's what they meant. So I'll tell you what about trees that grow. And trees that grow is a technique for attempting to tackle this problem. And I don't claim that it does in fact tackle the problem. In fact, I've had problems getting it to tackle the problem. So there's a bit of a question in here, which is like, what am I doing wrong, guys? So I'll tell you all about it. So it starts at this paper written by Shayan and Peyton-Jones. And you can kind of see the start of the abstract here about extensibility in functional data types. And I'm going to go into detail about what that means quite as precisely as I can. And a little bit more about me, by the way. I work for the CSIRO. CSIRO is a Australian federal government research organisation. It's very similar in function to NIST. I think you've got the organisation here in the USA. I look after a team of 9 Haskell programmers, or 9 functional programmers. Turns out we all just write Haskell. That's my job. And our job is pretty much to be awesome. That's it. So we crack open GHC every day. So this is what's stated in the paper, which is there's abstract syntax trees, at least 3, that are very similar for representing Haskell source code. All right, so you can imagine, there's one for expressions of one kind and another one that's got a slight change in some other case, and so on. So there's the GHC, the built-in one, template Haskell, and just third-party libraries. I'm sure there's more third-party libraries. They're all slightly different in the representation of Haskell. So that paper sets out to propose a solution to trying to unify these different representations and calling it trees that grow. And this is just sort of a summary of the problem that they're proposing to try to resolve. I like to look at it in these terms, the expression problem. Who's heard of the expression problem? Who has not heard of the expression problem? Okay, that's more than half. The expression problem is like the thing that keeps me up at night. Like really, it does. Like when that person on the end of the phone says, no, your name doesn't fit in the database, or whatever it is they say, I'm just like, that damn expression problem. I'm sure some people, actually one of my colleagues, she's Hungarian, and she tells me all about the problems she has, ringing up on the phone, my name doesn't fit. Oh, she's got a little accent on one of the E's or something. That's it, game over, doesn't fit on the computer. What? Come on guys, we can do better. So, I'll tell you about the expression problem. It was first actually proposed by Phil Wadler, and I'll do my best to explain it to you. So we all know the either data type. Some type, we have either an A or a B. We either have one A or we have one B, and no other possibilities. We can think of either as it has a B or some other stuff. Like I'm not going to talk about the other stuff. It's a B or some other stuff. I'm still telling the truth, right? It's a B or some other stuff. Exactly one B or some other stuff. This data type has exactly one B or some other stuff. And so does this data type. It has exactly one B or some other stuff. The other stuff is different in each case. but it all unifies at a b or some other stuff. Okay? So we should be able to write this function that given a b and then our data type defined over b, return a b. I should be able to write that function. Works on all the things that are exactly 1b or some other stuff, right? Should be able to write this function. If it is a b, update it, change it, like add 1 or something, or add 10, there it is. Right? So if I have an either int or some other stuff, if it is an int, it'll add 10. And if not, it'll just give me the other stuff. I should be able to do this. We want these functions to keep working on all things that are exactly 1b or some other stuff. I want to be able to come into this data type. I want to change some other stuff to something else, and all those functions keep working. They don't need recompiling. They don't need to ring up the schema department and ask for a change. That should just keep working. Right? There really is a schema department in most programming shops, right? It's like Andy in the corner or something. You know, Andy's over there. You go and ask Andy if you want to update the schema. That's what I want to do. And this is the expression problem. All right, the ability to keep adding constructors to our data types without having to change our calling code in contention with opening up the data type, and that way this can be anything. And then our code may need recompiling. So you can imagine like either is left or right. We'd say case left, case right. Then I add a constructor to either. Well, now I have to change my case statements because they're not exhaustive anymore. It's case left, case right. And the new stuff that I just added, I've changed the schema. And that contention is the expression problem. But these functions should keep working. There's more. Can I do that? So I want to write a render function. Like, for example, it responds with the HTML stuff about the B. It's a B or some other stuff. So I want a web page that goes, here's your B, or here's your other stuff. Right? That function should keep working too. Okay, like you change the schema now, you change the data type now, we have to rewrite the render function. Oh no. You know this problem, right? We were talking about this earlier when we filled out our visa for going to India. So when you go to India, this is from memory, so it's probably wrong. It's something like you're going there for a holiday, you're going there for business, or you're going there for a yoga retreat. Right? I'm serious, it was something like that. It has 3 constructors on the data type, and they've deliberately put 3 so that they don't have to do schema changes. And like if when you actually organise travel, there's all these like hacks. They're like, oh, just don't click that one, everything will be fine, and I'd make sure you do this one. It's like I'm going there honestly. Why can't I just say why I'm going there? Because the constructor doesn't exist on the data type. It's the expression problem. So we can add a constructor to the data type, but if we did, it is still B or some other stuff. That's what it is. And we want that render function to keep working, and all the others. Okay? So that's the expression problem as it relates to some types, like in the case where we're doing or between our choices. Like we're going there for business or conference or yoga retreat. We've got 3 choices. And the other stuff we can just say is open. It's like anything. Like if I add a constructor, it's just the other stuff has changed. It can be anything. But sometimes we want to talk about the specifics of the other stuff as well. And this is to say we want to close it off. We want to accept the penalty of closing it off so that we can be specific about the other stuff. So there's a type class called monad error that does close this other stuff off. I'm going to get to trees that grow. This is just the problem. I think I thought I put the code in there. Anyway, Monet arrow has some classes on functions on there that talk about the other stuff. It abstracts over the other stuff. There's a dual to the expression problem when it comes to sum types, and I hear about this one a lot. Like if I go on programming forums, I hear about this problem a lot. No one ever says it the way I want them to say it, which is to say, can you just solve the dual of the expression problem for me? It's like, yeah, man, no worries. But no one ever says that. They always say things like, I have two data types with the same field name. How do I unify them? Oh, there's, yeah, that didn't quite work out, sorry. There's one, I've screwed up. Moving on. Here is a product type, all right? This is a B and some other stuff, all right? A pair is a B and some other stuff. The other stuff is an A in this case, but we can just think of it as a B and some other stuff. There's a blob. It is a B and some other stuff. Do you agree? It's X, Y, and whatever I put there. That's the other stuff. Or another way of looking at it is like, I've got a person with a name, and then I make a blab with a name. Oh, how do I unify these two fields that are the same? So previously we had some types that were B or some other stuff, and now we have some data types that are B and some other stuff. And so this relates sum types and product types. So this is like an extension to the expression problem. We should be able to write this function, get the B. All right, like, how do I get the name out of the person and the name out of the employee? I want to just have one function that does it. Well, they've both got a name, right? You want this function. I only want to get the name out once. I want to make the name all uppercase, and I only want to write that function once. I have to write it for all the things that have names. Oh no, code duplication. I want to set the name to Bob in all of the different things that have name. I only want to have to do it once. I only want to write this function once. So I want to generalize over things that are B and some other stuff. Again, we can write a render function. It takes the B and it prints it out and some other stuff. And I only want to write the render function once for all things that are B and some other stuff. Does this problem sound a little bit familiar? I mean, is it just me sitting in the corner just running into this problem all the time, or is it you guys as well? Yeah? Yeah, data person equals person with a name, and then you go data blah with a name, and then you write a render function. It only works on person. Oh no, what are we going to do? Abstract it out. Blah, blah, blah. We might want to say, like, we've got a person with a name and an age and address, and we want to print out, we want to render it, and then I want to come along to the person data type and add a new thing. And it's like, whatever, do they like lollies? I want to just make a new field in my product type, and I want this function to keep working. Unchanged. Have I communicated a problem that is familiar? Really? Yeah. Okay, good. I was serious when I said this keeps me up at night. It really does. Because I spent a long time trying to solve it in different cases, and so in around 2008, I solved it to some extent, but I was not happy at all. Then the lens library came to exist, or the lens theory was developed a lot better. And I slept very well that night. It really did solve a lot of these problems.
Also sounds like something that row types solve.
Yep, row types is another way to get to that. So we're here to talk about trees that grow, but there are other ways too. So row types is another proposed way to get to tackle this problem. We want to have sums of products of sums of products of sums all the way down. We have like a really deep data type. I've got one in my office. It's called Python program. I have a data type called Python program in my office, and it is the entire Python specification in an algebraic data type. It's very deeply nested. All right, and I want to go down there, and I want to twiddle a little bit, and I want all of the calling code to stay just fine. Okay? just because I added a field to there. And by the way, when you write these data types, like if you write a data type for a language specification, you'll learn that the English bit is incorrect. All right, you run it against the spec, and no, that's not true. So you got to go and twiddle your thing. But we got there. So I want those functions to keep working regardless of what I do. So a little bit of algebra. Let's get into trees that grow. Everyone agrees with this statement? It's pretty simple. So who went to Emily or Alex's talk? Okay, did a bit of algebra. You all know that void is 0. Void cannot be constructed. So if I gave you, like if I said to you, make me a void, you'd go, well, I can't, there's no constructors. It's 0. And therefore, you should agree that this data type here is isomorphic to the one that doesn't have that constructor. Do you agree with that? All right, so if I deleted this constructor, nothing happened. You're never going to call it, because you're never going to get one of those. Algebraically, either is addition, it's a plus b, and this says a plus b plus 0. So the 0 just cancels. So this is an isomorphic data type. Agree with this one? Should all agree. Hope I got it right. I agree. X times 1 equals x. There's 1. Data unit equals unit. Make me a unit. Unit. You just call this constructor. And therefore, a times b times 1 just cancels. So this is isomorphic again. Okay? Everyone agree? This data type is isomorphic to a regular pair of a and b. It's the same thing as a times b. Well, this is also isomorphic. It's a times b times 1 plus 0. Am I telling any lies? That's good. What about this? So the distributive law of multiplication. Is everyone happy with that? All right. Therefore, this data type here, which is a times x plus b times x, is the same as this data type here. It's isomorphic. It is the pair of either a and b and x. It is a plus b times x. Right, this statement, algebraic statement here, is the same. This is the same statement written in code. I'm saying that either and x is of the similar structure to that. I can get a lens to this. Who is unfamiliar with lenses, by the way? Okay, I kind of assumed it a bit, but I'll go through it, right? So a lens is basically looking in a data type, and it's saying that there is exactly one thing of the target. All right, so in this data type, there is exactly one x. So that is to say there is a lens from this data type to that x. Okay? And there's also a lens of this data type to an either AB. Okay, so what I'm saying is, since these two are structurally equivalent, there is a lens from this thing to x. Okay, there is exactly one x inside this thing, even though the way it's written is as a sum type, there's an x on either side, but whichever side it is, there's always an x. So putting all of that together, trees that grow abstracts out those additional fields that I put in, like in the product type it was unit, and in the sum type it was void. It abstracts that out as a type family and says, let the caller decide what goes there. Okay? So in the undecorated case, we don't want to add anything, we put unit or void. When we want to add something, we just make a type parameter and twiddle it and change it. And say, well, it's not void anymore, it's whatever, the thing we want to add. This is a real problem in that this did keep me up, it still does keep me up at night. I had to write this data type called aircraft. I needed it for a reason. Don't worry about the reasons. So an aircraft is a product of these things, and a category is the sum of these things. And in the constructor you have the product of these things, and this thing is this, and this is this. Do you get my point? And that is that. And internal combustion engine is one of these. I really did have this problem. So I wrote all my code in terms of an aircraft. I wrote all this sums and products, and then I wrote aircraft at the top. And then you know what happens next, right? We create the schema and we put it in Postgres. And then the project manager just says, can we just add an image right down the bottom of the tree? This happens. That didn't really happen. I'm the project manager. So the rest was true. You have just been asked to add a field to a deeply nested product data type way down the bottom of your tree. That's what you've just been asked to do. Go down there and put an image in there. I don't listen to project managers, so I just keep walking. Only joking. So your data type tree needs to grow. So this is where trees that grow come from. And like I said, there's row types. There's other ways to try to tackle this problem. I'll tell you about trees that grow. And when I do, bear in mind that I'm still not sure that it solves this problem. Okay? So here's my internal combustion engine data type. This is what it really looks like when we implement trees that grow. So we don't write this. This is our raw internal combustion engine data type. We're going to implement it using trees that grow. And so we do this. All right? So we create a type family. I'm terrible at coming up with identifier names. I hope that's okay. X is a good one. Let's just put X there. That's great. Moving on. And then we add a field. And that field is the type family. All right? So that is to say, whoever is using my internal combustion engine data type, they get to decide what goes there, and they do it by switching around on that X. And then we write the raw form here, which is, if we just put unit there, that's as if nothing ever happened, right? Just multiply by 1. And pattern matching becomes pain, right? Like imagine you never wanted to add the field to ever, and then you went and pattern matched, you'd have to keep doing this. You're like, yeah, it's unit. You're like, yeah, it's unit over and over again. So you just write a pattern synonym. This is also in the paper. So this pattern synonym means that when you now do your case matching, you can delete the unit. You don't have to use it. Right, it'll only work when that type variable is a unit, or the type family instance, sorry. And so now it looks like this. And so we're back to having the same power that we had in the non-trees that grow approach, right? Because that's what it would look like if we didn't add that extension. And now we can add an image. This is how we add an image. All right, we create a new type instance of that type family for image. We write a type alias just because we're nice citizens. We don't really need it. All right, so basically in writing this bit of code, I have said that image can be added as a field to that data type, and I can use it that way. You might suspect a problem in that. I do. Right, like you can't just, like, so what? This didn't properly change the structure. So just to sort of give a trivial example, so that was for a product type. All right, so I've added in the type family as another field for the data type. That was on a product type, and then I've done the type instance for unit, because unit is nothing for product types, it's the identity. But we can do it for some types. If you do have a look at the paper, you'll find that the paper treats product types and sum types almost the same because it pretends that void is unit by the bottom value, which I have terrible, like I would never sleep if I ever did that. So this is a slight modification. All right, so I'm saying no, it's unit or void for sum or product. It's not just, this works everywhere. So I'll show you what we're going to do for sum types. So here's our sum type. We want to add a, actually this is adding a field, sorry. This is adding a field to a sum type. If I wanted to add a field to a sum type, that is to say, I want to say either A, B, and something, as if it's a product, I would simply add the type family instance on each of the constructors. Because as we know, there's that distributive law of multiplication. That means that there's a lens across this whole thing. Right? That factors out to being the pair of either A and B and this thing. Okay? From that earlier discussion. And so again, because it's a field, we instance it to unit, and that's the undecorated case. You can write pattern synonyms as well. Just the same, you know, like if we use that either data type as if it was not decorated with a field at all, we still get the full power of pattern synonyms and giving us the pattern matching. So here's what the lens would look like. That is to say, there is a lens from this thing to this thing. There is exactly one of these inside one of those. And I could write it. I will if I get a minute. So that was adding a field to a sum type. So I've added a field to a product type, I've added a field to a sum type. I'm going to now add a constructor to a sum type. And we do it like this. So again, a type family, we create a new constructor. That means I've got to come up with a name. Oh no, X, that'll do. Moving on. And then I pass in the type family value. And then I instance it with void. And what that means is, so if this were void, if this value were void, I'm back to being the undecorated case. And pattern synonyms. We can write prisms. Who doesn't know what a prism is? Okay, cool. We've got some talking to do. This is all right. This is interesting stuff. I don't know how I'll go over time. I think it's important to know what a prism is and a lens. Intuitively, you can think of a prism as if I look inside one of these, I will have exactly one of those or some other stuff. All right, so going back to the definition, if I look inside one of these, I'll have one of these, there it is there, or some other stuff. Okay? Let me just talk about prisms for a minute, because so prisms are an example of the thing that I ran up against in like the mid to late 2000s, where I could not come up with the thing that solved that particular problem, and it was really important. And what I was doing was I was parsing JSON. Everyone's done this. Like, you know, I went outside for lunch and someone threw a JSON blob at me. Happens all the time. And in the JSON blob, I'd do something like, you know, go onto the key of the object, and inside the key there'll be an array, maybe. There's an array or some other stuff, right? And then in the array, there's a third element, maybe. Right? And at the third element, there's another key, maybe. And like the maybiness all the way down, it's like it has one thing or some other stuff. This is different to a lens. Lens, we were all over. We had that nice and sorted out. Lens had exactly one thing inside of it. I wanted to say one thing, maybe, so that I could traverse down these data structures. And this caused great problems for me and my sleep. What I did actually, this is a funny story, is I wrote some terrible code. I knew it was terrible. I just didn't say anything. And Ed Komet, he saw my terrible code. All right? And he's like, what are you doing? It's like, yeah, I know it's crap, I just don't know the answer. And him and a few other people spent several months finding the answer. And I just sat back and they came up with the answer. It's like, sweet, it's called a prism. That's a true story. So a prism allows us to talk about this, is a thing or some other stuff, because it may not be there, right? As, for example, a JSON data structure. Whereas a lens is, there is exactly one thing in there. And just to finish that story, actually, you've probably heard of a traversal. Like, I can't talk about lenses and prisms without talking about traversals. So lenses are exactly one thing in there. Prisms are one thing or some other stuff. And traversals are zero or many things. All right? Like if you've got a data type with a, like data person equals first name and surname and the age, well, there's two names there. There's a traversal from person to the two names. Right, that's zero or many, in this case, two. So they're not pattern synonyms. So we can write these prisms, right? There is a prism from this data type to an A. It's an A or some other stuff. It's a B or some other stuff. It's the pair of A and B or some other stuff. That was the third constructor. Or there's a prism to the other stuff, right? Yeah, it's an A or a B, or it's an A and a B, or it's some other stuff. All right. You'll notice the thing about these prisms is it doesn't close off the data type, right? It doesn't say, and that's all it is.
There's no terminal.
That's it. Prisms don't talk about that. Other things do, but not prisms. The other things are called affine traversals. That's a completely different talk. So it's very interesting though. I'm happy to go and like talk about it tonight at the pub or something. But anyway, so this is what we can write these prisms across our data types. So the paper makes this claim. It's a true claim that it extends to existential types and generalized algebraic data types. I don't know. It's just a fact in the paper. It does. So what I'm going to do now is I'm going to like complain a little bit. These are my problems. I have a problem with trees that grow. This is like a cry out to the world. You know, hey, what am I doing wrong? So I had difficulty getting this to work. I do have something that I think you would call working, like is consistent with what the paper talks about. But there's always a penalty, and I'll tell you about the penalty. Maybe I'm just doing it wrong, like I'm owning up here. Maybe I don't know how to grow a tree. So someone mentioned row types earlier. That's one way to resolve or to try to tackle this problem. Another way is using what's called classy lenses and prisms and traversals and so on. This is how we would do it with classy lenses. So I would say this class denotes all things that have exactly one image, has a lens to an image. And I'd instance it for this data type here because it does have exactly one image. That was when we added in the image to the record, to the product type. But some people will complain about this and say, oh, we've got to write a new data type, right? Like we've got to say, oh, it's not an internal combustion engine anymore. It's an internal combustion engine with an image. It's a whole new data type. Now we can instance it. Whatever you think about that complaint is not the point. Let's just say this is a possible penalty. But this is the problem that I've had with trees that grow, which is that type variable. So let's just go back a bit just to point this out. Did you notice that either got another type variable? Right, and where's another one? Oh, there it is there again. Even internal combustion engines have a type variable. And the problem that I ran into is that, come on, is that type variable bubbles up your data type tree. So you can imagine you've got sums of products, and there's a type variable on each of them. And as you come up the tree, those type variables come with it. Okay? And my propulsion data type had 18 type variables. And I went searching through my Git history this morning so I could show it to you. Because There it is. It's somewhere way back in my... It doesn't exist anymore. It took me like half an hour to find it. I mean, maybe I'm doing it wrong, right? And just to point this out, right? This is pretty low in the tree. We're just talking about propulsion here. I've got like aircraft sitting up here, and I've got even more things up here. And like I got to this point, and I'm like, what's it going to be when I get up here? I'm going to have like 500 lines of type variables. I'm doing something wrong. 18. Something's gone wrong. And not only that, I run out at 26. I mean, this is my dictionary. It has 26 letters in it. So there's another approach, just to point out that there is another approach. It's called backpack, which aims to try to tackle this problem. It does so in a way that has penalties. It's pretty hard to talk about those penalties. You still get the type variable problem only in the existential case. Otherwise, it goes away. So you can think about backpack as being, it does everything that trees that grow does, except for the existential case when you still get the type variable problem. At least that's what I found as well. So this is how you would use backpack, is you'd write a signature file for your interface, and then you come along and you fill it in later on. A common complaint, if you use Haskell, you've probably heard of this complaint, which is all the different string data types. Oh, is it string list of chars, or is it text, or is it whatever, vectors and stuff. So the goal here being, well, we're going to defer the definition of a string, as long as it instances these two things, like as long as it can be compared for equality and can print out. And then this is the implementation. It says, well, in this case, it's going to be that one, a list of characters. So that's the backpack approach to solving this problem. So yeah, some quantifiers, that's in the existential case. That's an existential, right? So who's heard of ST? It's how we do variables in Haskell. How we do for loops. Someone once challenged me, actually. They said, oh, you can't write what is it? Here's a GCD function using a while loop. You can't do that in Haskell. I'm like, yeah, I can. I'm going to break out an ST. So I wrote a while loop. Good times. So I am still here. This is where I sit. Haskell doesn't have row types. This is how I continue to solve this problem. So if I went to this source file back here, and I went back up to like the master branch, where like the head, you'll see that this is how I'm doing it. I've given up on trees that grow. But maybe I'm doing it wrong. Hopefully I've communicated the problem to you though, which is really my goal for today. Which is, I want to be able to ring up the phone and just say, I add a constructor to the visa application. Come on, you know. I'm not there for a yoga retreat. So I'm keen to talk to you afterwards about this. Thanks. And I do have some code that I will write. How much time do I have? Like 10 minutes. It's going to take me longer than 10 minutes though. Okay. All right. Well, I'll take some questions now. Does anyone have any questions? Yep.
So, don't kill me.
Okay. All right. Not this time.
I look at this, and all I can think of, this is like the literal sales pitch for object-oriented programming.
Yes. Well, I don't think I sold you trees that grow, but yeah. Yeah.
No, but I mean, like, this is the classic problem that every OOP person that I've ever seen with a lot of experience says is why they like OOP.
Oh, well, they're claiming to solve it.
That has
Yeah,
an
they
expression
claim
problem
to
too,
have
though.
it.
Yeah,
It's for it to be a solved problem.
They have
And actually,
Nah.
arguably, if you're willing to give up everything else, it does seem to be solved. Like OOP systems.
No.
I think you and I need to go to the pub, man.
You can do that in
Hands
class.
off.
With a common list objective system, you can also do that for free. And you can do even better. You can add methods to an existing function so you can handle the new cases.
You're talking about Lisp or Clojure? Is that what you said?
Common list.
In Clojure, you can probably do it.
Yeah.
But in
Common
common
list,
list,
C++.
it's like,
So
I think it'll all do that.
I would love to have a beer and argue this because I don't believe you.
in Lisp, you don't have the types, but you have.
It's nothing to do with types. So like when we do go to the pub, I'm going to set some constraints. Like if you achieve these goals,
Okay.
like you win the argument.
Okay.
And then I'm going to just sip my beer while you try to do it.
Okay.
And my claim is you will not be able to do it.
So you don't have a beer, but what's one of those constraints?
Sorry, mate?
Like you don't have a beer, but what's one of those constraints?
I can't actually remember. So I last argued this in like 2008. So I'm going to have to go back to my argument and figure it out. Like I literally argued with Clojure and sat down and tried to figure it out. And I could not come to the solution. So just from the top of my head, some of the constraints are going to be, I need to be able to do both set and get on the 0 or 1ness, like on a prism. I need to be able to do composition. So if I have actually I can show you an example.
And are we saying that the algebraic concept is like because of the extent that the
So, like, the motivational problem, which was extend the fields without need to recompile, everything just works, but with some other stuff, is like the classic selling point C++ programmers. It's like, that is their bread and butter. They want all their modules to never change,
So
never
the
adapt.
thing is,
Yeah.
the expression problem has two different things.
Yeah.
So functional programming, it can do one thing and not the other. And the object-oriented programming is the reverse.
Yeah, I'll try. I'll try to explain that a bit better, right? So take either that has an A or a B, all right? I get the benefit of knowing that it is either A or B or nothing else because it's closed as a type, all right? And there's benefits to that, all right? Whereas object-oriented programming will just say, well, like I'll just say interface either, and it's just anything.
Yeah,
And I get benefits from that as well, but there's a contention there, right? So that is the expression problem. Like that contention is the expression problem.
You want to be able to close it arbitrarily?
I want to, so when I say, I want the benefits of being able to say it is either an A or a B and it's closed, and I want the benefits of that, but there's a penalty to that, which is I've got case left and case right over here in my calling code, and now I've got to modify that because there's a new case when I change the constructor.
I want to say the plain people have done something in C++ to do that, but I gotta go back.
Yeah.
I gotta go look.
I got the link on Slack. I added a link on Slack.
Which link is that?
I posted a link on Slack that shows functional side and object-oriented side.
Okay.
Okay, thanks.
Which right?
Sorry?
In general?
Yeah.
Okay. Yeah.
Have you looked at the library
Extensible.
extensible SP? SP, so it's extensible scalable products.
Don't think so.
Okay, so
Is that a Haskell library?
it's a Haskell library.
Okay. Is that does that use data.generic?
It does not.
Okay. No, I don't think I've looked at it.
But it sort of has sums of rank star and star star and star
Oh yeah.
star types.
Yep.
And using some essentially quantified variables for type class constraints.
Yep.
I think you can get to the point where each data type, even in the top one with the airplane,
Yep.
would only have one constructor.
Oh really? I can do that too with trees that grow, but there's a penalty that I don't accept. So hopefully I don't also have to accept that penalty. Yeah. I didn't show that, but.
What penalty is that?
No, not nested tuples. The constraints. So there are times when I want, if I go down the tree and I want to add two different types down on the tree, I need the two type. So I can unify them all back up to the same type, and then just have a sum of a product that gets added down here somehow. But I want to be able to distinguish the two different types down here So therefore, I want the two type variables to come up. All right, so if I said I wanted to add an A and a B, I could just like go X right at the top and then just put the pair A and B, and then they go down there or they go down there. But I want to be able to like distinguish where they were. Yeah.
I mean, it has its own disadvantages.
Okay.
You have like, all these type mass constraints, but this type is like a higher convention.
Yeah.
So when you want to resolve a certain type class instance, oftentimes it's these.
Yeah. I just thought of some code that I wrote about 5 years ago. Yeah. So actually, a real example that we have at work is we have this data type called Python program. It's actually Python 3.5. And we also want to write Python 3.6. And we don't want to have we want our functions to use both, right? Except where they're different. So I did this 5 years ago for Java class files between version 1.4 and version 5, I think. Or no, 1.2 and 1.4. Hopefully it's on the right. It looks like I'm on the right commit. But let's have a look if I am. Yeah. Here we go. All right, hang on. We're not even, here we go, here we are. This is a parser for class files. And these are the lines that fill the screen are the constraints. Okay?
Yeah, so I would say that we
Yeah.
have a lot of type classes.
Yeah, look, there it is. That's the parser. And it's constrained by that.
Is that using trees that grow? Or?
No, this is using, it's using classy optics. So it's like taking classy lenses even further up in the abstraction, which I no longer think is a good idea. You'll see this here. This is more general than a prism. It's trying to be more general than a... So there's a relationship between lenses, prisms, and traversals that unify at another thing, and I've tried to use that unification, and that's just not a good idea.
Why?
Because you do all of that work and the benefit's not very big. Yeah.
Is it a con extension?
Yeah. A lot of that actually is just generalizing list. Like you can see empty and cons. Yeah.
So have you seen the NanoPass compiler framework?
Nail.
Construction framework?
Nail.
Pass.
No, I never heard of it.
So they take a slightly different approach that maybe might be more appealing. I don't know how applicable it will be.
Yeah.
But rather than requiring that they all fit into the one data type, they
Yep.
make it really, really easy to create trivially extended new data types that are diffed. So
Yep.
you have a syntax where you diff an old data type with a new one, say, I want to change this, add this, do this,
Yep.
and it allows you to automate. So if you want to write something that has those new fields, you can write it and it will automate sort of the
Okay.
process.
Yep.
And so you don't have to have any of the boilerplate, and it does constraint and type checking on
Yep.
the structure. And so it solves the problem by saying, well, rather than trying to force everything into one data type, we'll just allow many data types to be constructed without a high syntactic burden,
Okay.
and then allow you to work off of that.
I'm glad other people are working on this problem.
Yeah, I don't know if that's appealing.
I just think all of us need to get together and just damn well figure this out. Like, what is the correct solution to this problem? Yeah, I realize, like, I'm going to say classy lenses and we're going to get drunk at the pub and all that. I'm just not... I have a criteria that needs to be satisfied before I can say it is solved, and I'm skeptical.
Your solution is like version you're good.
Yeah, this works on both versions of Java class files.
Well, I mean, open types and closed types are fundamentally mutually exclusive.
Sorry? They're not mutually exclusive. Is that what you said?
They are.
Open types and closed types are mutually exclusive.
Yeah, they're different types. Yeah.
No, different types.
Yeah, I know. Yeah.
But it seems like at some point you're going to have to close it off.
Yeah.
So you're either going to have a lot of, if you want all the generic polymorphism functions,
Yeah.
you have like all these different products with sums. You will at some point at the very top close to name will have to
Yep.
fix that type.
Look, maybe we just get together and say there's just a universal law that says that's the case, and I'm cool with that.
I can tell you how we solve an APL. I don't think that'll be as applicable, but it is a totally different approach.
Okay.
And so in APL, you use an inverted table, which separates all your fields.
Yeah.
So adding a new field costs nothing
Yeah.
in terms of runtime or change of code. If you throw a new field in there, only functions that worry about it have to worry about it. Otherwise, it's exactly the same as if all the rest of your code stays exactly the same. Because the individual fields are decoupled from the nodes themselves, so that they're not tied together. So the description of the node does not have to require any change in the field type. So adding a new field is essentially free.
Okay.
But basically it means that where your record types are like row major, if you will, so every record,
Yep.
so adding a new field requires that you have to add a bunch of data, and that's represented in the type system. If you invert it, transpose it so that you've got like columns, so then adding a new column doesn't change anything else.
Yep.
It doesn't have any effect.
Yeah. That's like row types. Yeah.
that's-
All right. Looks like we're out of time. I look forward to having a beer and talking about it. Thanks for listening, guys.